Hey everybody, in this video I want to take you through continue to kind of idea that we're trying to learn, which is generating information that would be used in equations from either statements or other sources. In other words, what we're really trying to do is we're trying to make connections between graphs and equations. And in this case, it turns out that we're trying to make connections between table of values and equations. So I want you to look at the question or the thing that I'm trying to do here, and it says, state the period, the amplitude, and equation of the axis of the trigonometric function that produces each of the following tables. Then use this information to write the equation of the function. In other words, there's a single trig equation that will describe what's happening in this table of values. So this is, when you break this problem down, it's actually very manageable. It may look a little intimidating at first just to see these random x and y numbers and ask yourself, how on earth am I going to come up with a trig equation? But when we boil it down to the essence of the question, all we're really trying to remember is that to come up with a trig equation, we have y equals a, sine or cos. In this case, we'll just use sine, although it is possible to generate a cos equation from this as well, but let's not go there yet. So y equals a sine k x minus d plus c, okay? And so in this case, all we do in order to generate a proper trig equation is we say to ourselves, what would the a value be? What would the k value be? What would the d value be? What would the c value be? And once we've established those, we can come up with the equation. So we might as well do the easy part first. The easy part would be to figure out the a value. The a value, the amplitude, and a is equal to max minus min over 2. And the maximum value that this function reaches apparently is 18. It would tell us if it was something else, believe me. The minimum is negative 18, and we're dividing all of that by 2. So that means that we have 36 over 2, which is 18. So a equals 18. Okay, and we also should know the equation of the axis. The equation of the axis, which is our c value, and that's going to equal to max plus min over 2, which will equal to 18 plus negative 18 over 2, and that equals 0, and so our c value is equal to 0. Okay, so everything moving along smoothly here, and then, you know, we might say, okay, well, have we hit a glitch here? Is there anything that possibly could throw us off? Well, it does ask for the period. The period means that we need the k value, and period equals 2 pi over k, but the question is, what is the period? Well, the period of the graph can be found by finding how long it takes for a repeating feature to occur on a graph. Now, if you look at a graph, the most common way that students really like to figure out period is just figure out the distance between two peaks or two troughs, right? So in other words, the repeating feature of a peak occurring, right, would give you, say, however much distance it took for that to happen would be the period of the graph, right? And so that's a really easy feature on a graph to find, and so it's usually what the choice that students make is when they're trying to find period. Same thing with the troughs, the bottom of the graph, right? You look at the distance between two troughs, and you say, well, that's the period. Okay. Well, if we look at the table of values that we've been given here, we only see a single peak and a single trough. Okay, so now that leads us into a bit of, a problem, because then we're like, well, I can't do the period of the graph that way, so what do I do? Valid question. So there's a couple of approaches you can take. what some students do is they say, aha, I know what I'll do. I'll just go ahead and see how long it takes for the graph to get back to the same y value. Because after all, if the peak occurred, once and it occurs again, then that means that I'm just finding the difference between two of the same y values, and that will give me the period. And to those students, I would say good thinking, but you have to be very careful with that strategy. Let me show you why. If you just looked at a sine graph, y equals sine x, and you said, okay, the way I'm going to figure out the period is just to see when it reaches the y value of 0. Oh yeah, look, there we go. It reaches a y value of 0 here and a y value of 0 here. And so I know that the period of the graph would be pi, and they would be, of course, incorrect, right? Because it reaches 0 again at 2 pi, right? So you can't just make the assumption that however long it takes for a graph to reach its same y value is the period of the function, because if you do that, then you might make the mistake of forgetting that in the case of sine and cos, it reaches the equation of the axis 3 times in a single cycle, all right? So if it reaches the equation of the axis 3 times in a single cycle, the period of the graph will be the distance between the first and third time, not the first and second. So in this case, we know that the equation of the axis is y equals 0, and so what we know is that you can see it reaches 0 3 times. So the period of the graph would be the distance between the first and third times that it reaches the cycle. So the period of the graph, to cut a long story short, is equal to 2 pi, which means the k value is 1. But let's say that kind of like method of finding out the period of the graph kind of leaves a little bit of a bitter taste in your mouth. Like it just doesn't seem neat enough, or it seems a little bit too open to making mistakes. Well, another way that I like to do it is I like to know this fact, and it's a true fact for any sinusoidal graph, that the horizontal distance that occurs on any sinusoidal graph between its peak and its trough, that horizontal distance will always be 1/2 of the period. Okay, so if you know how much horizontal distance there is between a peak and a trough, then you know 1/2 the period. So if you want to know the full period, you just times that by 2. So if you look at this example up here, the peak occurs at 90 degrees, or pi over 2, right? 90. Think in terms of degrees per second. The trough occurs at 270. So the difference between 270 and 90, right? 270 minus 90, or if you prefer, 3 pi over 2 minus pi over 2. Well, that's equal to 180, or if you prefer, just pi. So pi is half the period, or 180 is half the period, so the full period would be 180 times 2, or pi times 2. So the full period would be 2 pi, or 360. Okay? And then what you got to remember, of course, is period equals 2 pi over k, and since the period is 2 pi equals 2 pi over k. If you isolate for k, you find that k equals 1. Okay, now that brings us to our last thing in this, which is phase shift. Phase shift, surprisingly, is probably the most difficult thing to determine when you're given a table of values. And in order to get phase shift correct, what you have to do is you have to ask yourself basically this question. On a graph that has not been horizontally translated, where would I expect a certain feature to occur? And then if it's not occurring there, what is the difference between where it is actually occurring versus where it is supposed to occur? Okay, and that is the key question you want to ask yourself with phase shift. So in this example, it's a sine graph, and we know that with sine graphs, they start out at the axis, they go to a maximum, get to a minimum, and return to the axis. And if you look at this graph, it's starting at the axis, going to a maximum, back to the axis, down to a minimum, back to the axis. So there is no evidence in the graph to suggest in any way that there has been phase shift, because it is acting in the way that a normal sine graph would act, okay? If we decided to use a cosine graph to model this situation, well, then we'd have a different scenario, but we'll talk more about that when we get to modeling trig functions. For our purposes though, the answer to this question is just going to be y equals 18 sine x. Done. In the next video, we'll do the second one, and we'll see how you do with that. Thanks for watching.